The customer class here contains a definition for a customer name property. And both the corporate customer and individual customer classes inherit that property. You use this property in the corporate customer class the same way that you use it in the customer class. Corporate customers have a single name. But while it's true that individual customers have a name, their name is a combination of a first name and a last name, and it gets more complicated from that. Therefore, we added properties for first name and last name to the individual customer class. So then, what do you do with the customer name property? Well, one of the options would be to move this definition out of customer. So I'll go ahead and cut it and put it into corporate customer, because that's where it's actually going to be used. So I'll paste it in there, and of course I need the backing field as well. Cut that and put that in corporate customer. Okay, so now customer name is implemented just in corporate customer. Individual customer doesn't use it, and so this might seem like it's a good solution. Okay, except there's a problem here. If I come back over to my main application code, notice that I now have a problem. It says the customer doesn't contain a definition for customer name, and no extension method blah 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 accepting blah 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 can be found. Are you missing a directive or assembly reference? Well, no. The problem is that I actually changed the customer class. Okay, so the idea here is that I've created a customer class, I've used it in various applications, and now it occurred to me that, well, I have a property that really shouldn't be part of customer. It should be part of one of the derived classes because it really only used in that derived class. But I've now broken all of that other application code. So there's really two options. One option is to go fix all of the applications that use that code. So I wouldn't use customer name here. I would actually do code like this. Notice that this code is not broken because I have customer name implemented within the corporate customer. Okay, that may or may not be feasible. And so I'm going to come back here and undo those changes, because there's another way of taking care of this. And kind of the scenario that I'm going to be following here is that it's conceivable that a customer name property could be useful for the individual customer class too. What it's going to do is concatenate an individual's first and last names into a single string. So the situation that we have is that both derived classes can make use of a customer name property. May or may not work for your customer objects, but that's okay. But the behavior of the property for individual customers is different than what is implemented in the customer class. In the customer class, customer name is just reading and writing that backing variable, which doesn't really work for individual customers. All right, so this is a prime example of a great time to override a member. We want to override the functionality in the individual customer in order to have it behave differently while leaving the corporate customer functionality untouched. Okay, so the idea here is you can override the customer name property in the individual customer class and change its behavior. So the first thing that we need to do is actually tell this property in the base class that we can override, that derived classes can override this property. And that's why I have the virtual keyword there in the customer name definition. Okay, so this is telling C# that derived classes can override this property. Without that virtual keyword, I wouldn't be able to get a compile time error if I tried to do what I'm going to show you next. Okay, so once I do that, I come over here to the individual customer and I override that property. So the key here is using the override keyword in this definition. If I don't include that, then notice I get a kind of olive green squiggly, and it says individual customer name hides inherited member customer.customer name. To make the current member override the implementation, add the override keyword. Otherwise, add the new keyword. Okay, so in this case, I don't want to hide the underlying functionality, so I'm going to include the override keyword there. Okay, and don't worry about those other situations. They're kind of advanced for our purposes here. Okay, so what this property does is when I call the getter method, when I read the value of the property, it's going to return a concatenated string with the first name, a space, and a last name. And again, in this very simple application, we only have first and last names. If I assign a name, a string, to customer name, it's going to split up that string into the two parts. So it's going to start by using the index of method of a string value. So because this is a string type property, value here itself is of type string, as you can see there. And so it has the index of method, and that's going to return the location of that space. And then I can use the substring method to split off the first name, 0, to that index location, and then split off the last name starting at the index location and adding 1 to it. Okay. Keep in mind that all of these operations are 0 based, so the locations of things within the string are 0 based. All right, so now the result of overriding this property is that when I use the individual customer class, I can assign a string, say Don Kiley or John Smith or whatever, to this, and it will split it out and split it into the first and last name fields. And when I read the property, I'm going to get a single string that has the first and the last name. All right, so hopefully you appreciate just how cool this is. Because, again, stepping back, I have base class functionality that is available to all derived classes. It doesn't quite work for individual customers, so I can override it. And if I have 15 classes that derive from customer or whatever other base class I'm working with, and I only need to override this. This is the only thing that makes this derived class different. All I need to do is implement this one change, override that one property in the definition of this derived class. And otherwise, I can inherit all the base class functionality, and I'm done defining this uniquely useful class that derives from the base class customer. Okay, so come back over here and have some code that exercises that. All right, so what this code does, and again, this is in program.cs, I'm creating a corporate customer, newing it up. I'm assigning a string, Big E Industries. This is going to use the base customer functionality, which is just going to store that entire string to the underscore customer name field. If I come back over here, it's just going to read that string and assign it to that backing field right there. And then I'm going to read the customer name property. In this case, I'm newing up an individual customer. I'm assigning the first and last names there, and then reading the customer name. So this is going to use the properties that are defined within the individual customer. There's first name and last name, just assigning the value to the backing field. And then I'm reading the customer name, and so it's going to execute this getter and concatenate that together, and so it's going to return John Smith. And this code does essentially the same thing. I'm newing up an additional individual customer, but this time I'm assigning Mary Jones to customer name, and then I'm reading the individual properties, first name and last name properties. And so this is hopefully going to demonstrate that our code that shredded the Mary Jones name into two different strings in first name and last name actually worked. Okay, Go and run this. And I want the overridden members, D. All right, and you can see the corporate customer is Biggie Industries. The individual customer, the first one, is John Smith. So we assign the first and last name, and we're getting the concatenated name back, John Smith. So that's a single string displayed then on the console. Here we assign customer name, and it was split into the first and last names, and we display it as Mary Jones. Now, as we've seen, you can add capabilities to a derived class just by adding properties and methods that don't exist in the base class. So we did that with here the corporate customer adding a sales rep and credit limit, and in the individual customer adding first name, last name, birthday month, and birthday day. But there's another technique you can use, which is overloading members. By overloading members, you keep the original property or method of the base class and create a new version with different parameters and or return values in the derived class. So one way that we did this within the code is the record sales. Okay, not scrolling to it, so I'm going to go to record sales. There we go. Okay, so again, this is in the base class, the customer class. So this is implemented with 3 parameters. A customer ID to identify which customer we want to record these sales for. The amount of the sales, so that's presumably a dollar figure of some sort. And then a number of units. All right, and then this method goes on, and again, keep in mind this is the base class implementation of record sales. So I new up an XML writer settings. I set some settings to make it human readable. And then I new up an XML writer. Actually, I don't new it up. I use a factory method to create it. I'm going to put it in the C Learn Now folder, apply those settings, and then I'm going to write out information about the customer sales. And specifically, I'm going to include the customer ID, the sales amount, and then if the number of units is -1, put unknown. If it's a 0 or a positive number, I'm going to write the number of units, and then write the elements, and then increment and then add to the cumulative sales for this customer. Okay, so that's the base class functionality. But we need to change that within the corporate customer class. So I'll come over here to corporate customer, and I'll go to the record sales method. And what this does is it adds the sales rep parameter there. Because as part of recording a customer or a corporate sale, we need to record who the sales representative was. Presumably they're going to get a commission or whatever reason that we need to record that. All right, so this has 4 parameters. So we're overloading the record sales method. Even though we're doing this in a different class, this is code in corporate customer, and that other code that I showed you is in customer, these are going to apply. I'm still going to inherit that other record sales method with 3 parameters, or if I call it with 4 parameters, it's going to use this record sales in corporate customer. Okay, so the code has to be re-implemented, and the main change here is that added this line of code right there in order to record who the sales representative was. So corporate customers are going to have an additional element in that XML file. Individual customers won't have that because individual customers are going to continue to use the base class functionality that doesn't take the sales rep parameter. Okay, now, again, to keep things simple, I implemented this overloaded method this way. This is a lot of redundant code between the base class functionality and the derived class. In a real application, what I could do is place the repeated code in a separate method and then call that from each version of the record sales method. So that would make it easier to maintain the code. Okay, so just keep that in mind, that there's various ways of reducing the redundancy of code when you overload methods like this. Okay, there's one other thing I need to mention here. Remember that I'm accumulating sales. When I record sales, I'm adding it to cumulative sales. So if I press F12 on that to go to the definition, notice that the definition of that variable is in customer.cs. So I'm not defining an instance of cumulative sales here in the corporate customer. I've already done that here, and I can use that. The way that I can use that is because I included this protected keyword right here. If I get rid of this and save that file, I can come back over here to corporate customer and come back down to my method, and as you can see, I now have a red squiggly line. Hover over it, it says customer.cumulative_sales is inaccessible due it to its protection level. So the reason I'm getting that error is because I have this as essentially now a private variable, which is only available within the class in which it's defined. Nothing magic about that. It's private to the customer class. Derived classes don't automatically get it. So what I do instead, I hit Control-Z to put protected back in there. So now I'm declaring cumulative sales as protected. A protected member is only available in the class in which it's defined, so in the customer class, and any classes that derive from that class, like corporate customer and individual customer. It's not available, it's not visible to any external code. So if I tried to access cumulative sales directly from code that uses the classes over here, it's not going to be visible, and I'm going to get a compile time error, and I won't be able to compile the code. Okay, so I'm going to save that change. And now, once again, because it's protected, cumulative sales is available in derived classes. This works just fine. Okay, so let's use those overloaded members. So here we're instantiating two new corporate customers, assigning Biggie to customer ID, sales rep is Ed, and then I'm using that new version of record sales to record the sales. Customer ID, the sales rep, $100,000, 500 units. But here, for whatever reason, I'm not going to record the sales rep. Maybe this was an online purchase or whatever. So I'm recording the name. The customer ID is small, so presumably small industries. And I'm just going to record the customer ID, the amount of sales, and the number of units. Okay, I'll go ahead and run the code. And select E for overloaded. Doesn't do anything visible. But now I can go over to see Learn Now and look at Biggie Sales. Open that up in Internet Explorer. And there you can see that I recorded the customer ID, the sales rep, $100,000 in sales, which was 500 units of whatever this product is. And then I can look at small sales, right there, and see that it recorded all the same information, but not the sales rep. So the key takeaway here is that by overloading the methods, I can use both of them from an instance of corporate customer. From individual customer, only the base class record sales is available. So if I tried to use it with 4 parameters, that wouldn't be available for the individual customer class. Okay, so that still raises an issue. If we go over here to individual customer, and I come down here and come down, we can see that it also overloads record sales. But this one contains logic. There's no sales reps involved in individual customers, but it does include logic to determine whether a customer receives a 20% discount on his or her birthday. And then after determining the discount, if there is any, you want to record the sales. In this case, the code to do that already exists within the base class. I don't need to change how the base class does things, because the change as a result of somebody's birthday is to change the amount of the sales. I'm still only going to call record sales with 3 parameters. I'm still using the base class functionality. And I also don't want to copy code from the base customer class into my derived class, because that's redundant. Okay? I can avoid that in this case. All right, so this method is defined 5 parameters. So it's clearly overloaded from the base class, 3 parameters versus 5 parameters. So the C# compiler is able to uniquely tell on an individual customer derived class, if I pass it 5 parameters of the correct types, this is the overloaded version. Then I have the logic to check to see if today's month is equal to the birthday month, and if today's day is equal to the birthday day that is passed in. And if it is equal, if both of those are equal, then I'm going to take 80% of the sales, and that customer gets a 20% discount on their sales that day. Then, in order to call the base class record sales, all I need to do is use the base keyword, call the method name, and pass in the 3 parameters that it takes. And now I've identified that I want to call the record sales that is part of the base class, and it's going to call this code. Because again, all I've done is I've changed the sales. I'm not needing to record any additional information. I'm not recording the birthday day or month or anything like that. All I need to do is record the same information, so this code still works just fine for individual customers. All right, and then I have some code that demonstrates that. And so once again, I'm newing up a couple of individual customers. I'm setting the customer ID to Smith. I'm assigning customer name to Jane Smith, which will shred the name into first name and last name. Birthday month is May 30th. And then I have a second customer, Bruce Jones. And I'm going to set this to, let's say that my system clock is set to April Fool's Day. It is in fact April Fool's Day. And I'll save that change. And so this customer is not going to get a birthday discount, and that this customer is going to. And then I call record sales. In both these cases, because I'm passing 5 parameters, it's going to call the record sales, the overloaded version that I defined within individual customer. All right, I'll press F5 to run the application. And F, and then I can go over to my Learn Now directory, and I have my Smith sales, and as you can see, Smith is full $1,000. If I come back over to my code, Smith's birthday is May 30th, so no discount there. And then if I go to Jones sales, notice that the sales amount is $800, even though I specified the sale was $1,000, because today is Jones's birthday, and so Jones gets a 20% discount on the sales. And both of them bought 50 units, so that wasn't changed. So it was just the sales amount that changed as a result of whether or not it was the person's birthday. So the way this works is that you now have 2 overloaded methods called record sales from the perspective of an individual customer. As usual with overloaded methods, the compiler selects which to invoke at runtime based on the number and type of parameters that you pass to the method call. When you include 5 parameters when using an individual customer object, the compiler selects the overload that I just showed you. defined within the derived class. It then explicitly calls the base class's record sales method. And that's what was happening right there with that statement. But on the other hand, if you invoke record sales on an individual customer object with just 3 parameters, the compiler will select the overload of the customer base class.